Have you ever thought about our sun, that big, bright star that gives us life? We see it every day, and it seems so constant, so reliable. But what if I told you that our sun has a secret life? It has moods, it has cycles, and sometimes it goes quiet. This isn't science fiction. It's a real mystery that scientists are trying to solve right now. We're talking about periods of solar silence, and understanding them could be crucial for our future. So, what exactly is a solar silence? Normally, the sun is a bustling hub of activity. It has an 11-year cycle where its magnetic activity waxes and wanes. At its peak, we see lots of sunspots, solar flares, and massive eruptions called coronal mass ejections. These events can send charged particles hurtling towards Earth, creating beautiful auroras, but also potentially disrupting our satellites and power grids. Then, the activity dies down, and a new cycle begins. It's a rhythm we've come to understand pretty well, but sometimes, something different happens. The sun doesn't just quiet down for a bit. It enters a prolonged period of deep inactivity. The most famous example of this is the Maunder minimum. Imagine this. From the year 1645 to 1715, for a full 70 years, the sun went eerily quiet. Sunspots, which are usually a common sight for astronomers, almost completely vanished. Records from that time show that in some years, not a single sunspot was observed. For comparison, in a normal solar minimum, we might still see a few, but during the Maunder minimum, it was like the sun just went to sleep. This wasn't a one-off event either. Looking back through historical records and using clever scientific techniques like analyzing tree rings and ice cores, scientists have found evidence of other grand minima, like the Spira minima in the 15th century and the Dalton minimum in the early 19th century. Each time, the sun's activity dropped to unusually low levels for several decades. Now, here's where it gets really fascinating, and a little unsettling. We don't know why this happens. We have models of the sun's interior, a process called the solar dynamo, which generates its magnetic field. These models are great at explaining the normal 11-year cycle, but they struggle to explain why the dynamo sometimes sputters and nearly shuts down for decades at a time. Is it a random fluctuation? Is there some deeper, longer cycle at play that we haven't discovered yet? It's one of the biggest unanswered questions in solar physics. You might be thinking, okay, so the sun gets a little quiet. Why should I care? Well, this mystery isn't just an academic puzzle. It has real-world consequences for us here on Earth. During the Maunder minimum, something else was happening on our planet. Europe and North America experienced a period of bitterly cold winters. This era is often called the Little Ice Age. Rivers that rarely froze, like the River Thames in London, froze solid for weeks, hosting frost fairs on the ice. While the sun's silence wasn't the only cause, volcanic activity also played a big role. The link is too strong to ignore. A less active sun emits slightly less energy, which can have a cooling effect on our global climate. But it's more complex than that. The sun's magnetic field also acts as a shield for the solar system. When it's strong, it deflects some of the high-energy cosmic rays coming from deep space. But when the sun is quiet and its magnetic shield is weak, more of these cosmic rays can reach Earth. Some scientists believe these cosmic rays can affect cloud formation, which in turn influences climate. So, a quiet sun could potentially change our weather patterns in ways we're still trying to understand. And it's not just about the climate. Think about our modern world. We are more dependent on technology than ever before. Our entire global infrastructure, from GPS navigation and communication satellites to power grids and the internet, is vulnerable to space weather. While a superactive sun poses the threat of powerful solar storms, a grand solar minimum presents its own set of challenges. For example, with a weaker solar magnetic field, the Earth's upper atmosphere cools and contracts. This reduces atmospheric drag on satellites in low Earth orbit. That might sound like a good thing, but it also means that space debris, the junk from old satellites and rockets, will stay in orbit for much longer, increasing the risk of collisions. The big questions remain. When will the next grand solar minimum happen? Could we be heading into one now? Some recent solar cycles have been weaker than average, leading some scientists to speculate that we might be on the cusp of a new period of solar silence. Others disagree, arguing that it's just normal variation. The truth is, we can't predict it with any certainty. We don't know the trigger. And here's another chilling thought. How extreme can it be? Was the Maunder minimum the most extreme it can get? Or could the sun go even quieter, for even longer? What would that mean for our climate and our technology? We are essentially living next to a star whose long-term behavior is a mystery. We're flying blind. This is why solar research is so incredibly important. Scientists around the world are using state-of-the-art solar telescopes and spacecraft, like the Parker Solar Probe and the Solar Orbiter, to get a closer look at our star than ever before. They are trying to peel back its layers and understand the engine that drives it. By improving our models of the solar dynamo, we hope to one day be able to forecast these long-term changes, just as we forecast the weather. Knowing if a grand minimum is coming would give us time to prepare. We could adjust our climate models, better protect our satellites from cosmic rays, and manage our space environment more effectively. It's about moving from being reactive to being proactive. The sun has been the center of our world since the dawn of humanity, a source of light, warmth, and wonder. But it's also a complex and sometimes unpredictable star. The mystery of its silences reminds us that there is still so much to learn about our cosmic neighborhood. Solving this puzzle isn't just about satisfying scientific curiosity. It's about understanding the forces that shape our world and ensuring our future in a dynamic solar system. Thank you so much for watching. If you found this cosmic mystery as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our universe. And let me know in the comments what you think. Are we heading for a new Maunder minimum? See you in the next video.